Hey everyone, here's our math problem for today. Which is greater, 3.14 raised to pi or pi raised to 3.14? We know that the approximate value of pi is 3.14. So these two values, 3.14 and pi, are very close with each other, with pi being slightly larger than 3.14. But if 3.14 is the base and pi is the exponent, compared to pi as the base and 3.14 as the exponent, which one is greater? You can pause the video and see if you can analyze this interesting math problem. Now let's solve this problem together. Since we have here exponential numbers, we can reverse the process by taking the logarithms of both of these expressions. So let's take the natural logarithms of these two expressions. Now, using the properties of logarithm, this exponent pi can be appended at the front to have pi times ln of the base 3.14. The same thing at the right side, we have 3.14 times ln of pi. To eliminate this coefficient of pi and 3.14 to both of these expressions, let's divide both of them by 3.14 pi. And at the left side, this pi and this pi are cancelled out. And at the right side, 3.14 divided by 3.14 is also 1. So here is our resulting expressions. Notice now that the form is ln of an input over the same number. The same thing here, ln of pi over the same number pi. So the form now of this function is ln of an input x over the same value x. And in order for us to decide which between this blue expression or this yellow expression is greater, we need to investigate this function. And we need to note that x here cannot be 0, and x also here must be positive because the natural logarithm is not defined for a negative input. So let's put that condition that x must be greater than 0. So let's visualize this function. F of x is equal to ln of x over x. From its graph, notice that the graph is increasing. For x is less than about 2.718, then it started to decline as x becomes bigger and bigger. But we need to prove mathematically that the maximum height of the function is really at x equals about 2.718. And how can we know what is the maximum height of this graph? Well, we can use the first derivative. So let's find the first derivative of f, and that is f prime of x. We have here a quotient. At the right side, we need to find the derivative of a quotient, which is equal to the denominator x times the derivative of the numerator, and the derivative of ln of x is 1 over x, minus the derivative of the denominator x is 1, and we copy the numerator ln of x divided by the square of the denominator. Simplifying, x times 1 over x is 1, 1 times ln of x is ln of x, and copy the denominator x squared. So in order to find the maximum height of our graph, we are going to let the first derivative f of x be equal to 0, and graphically it looks like this. This red curve is the graph of f of x, which is ln of x over x. The first derivative of this red curve is 1 minus ln of x over x squared, which gives us the slope of the curve at any x value. And if we let this to be equal to 0, we want the slope to be equal to 0 so that the line is a horizontal line. And that will happen when we have either the maximum or the minimum value of the function. Since the curve here is concave downward, what we are computing here when we let the derivative to be equal to 0 is the value of x that will give us the maximum value of the function. So let's solve now for the value of x. Multiplying both sides by x squared gives us 1 minus ln of x equals 0. And we add ln of x to both sides of the equation. And from here, we take the exponentials of both sides of this equation. And so e raised to 1 is e. E and ln are inverse function that cancels each other effect. So we now have e equals x. So what we have just shown here is at x equals e, which is approximately equal to 2.718, we have the maximum value of the function ln of x over x. So for any x value less than e, this function is increasing. For any value of x greater than e, the function is decreasing. So let's take note of that observation. So we now say that at x greater than e, f of x is decreasing. Now, our x values here that we are interested in are x equals 3.14 and x equals pi. And both of them are greater than e. Pi is greater than 3.14 and 3.14 is greater than e with an approximate value of 2.718. So that means these two x values are at the right side of e, where the function is decreasing. So the higher is the x value, the lower is the value of the function. And so we now have this inequality. ln of 3.14 over 3.14 must be greater than ln of pi over pi. That is because the function is decreasing. The lower is the input, the higher is the value of the function. And so from here, going back to our previous computations, this last part is obviously this last part of our previous computation. And so this question mark here at the bottom should be greater than. Unless we perform multiplication or division by a negative number, the direction of the inequality will not change. So from this second to the last line here, going to the third to the last line, we did not perform any multiplication or division by a negative number. So that means this question mark here will remain as is. That is the same direction as the previous one, the same here, that is greater than, and also the same with our original inequality. Notice that pi and 3.14 here are both positive. So we maintain the direction of the inequality, and so we now have the answer. 3.14 raised to pi is greater than pi raised to 3.14. And see the beauty of mathematical thinking. Thank you very much, and we hope to see you again in our next video. Bye for now.